Good afternoon. Welcome back to our session at 1 o'clock. I would like to welcome again all the participants and attendees to this final day of the SME Resilience event, and this is the final session focusing on one of the most important topics today, which is about resilient supply chains. My name is Aniko Balogh, and I have been the moderator of these sessions and will go on with you today. Some of you have already participated in the previous sessions, but for those who are new here, I would just like to tell you that I'm representing the organizer project, which is Co-Versatile. We are a Horizon 2020 project supported by the European Commission, and we started just 2 years ago after the breakout of the COVID pandemic to focus on such disruptions, which already happened and may happen in the future. And now I'm just going on with our topic today, like the supply chain crisis during the lockdown, the chip crisis, the Suez Canal container crisis. And we would like to reinforce SMEs to improve their preparedness during these crisis situations. And in this session, we would like to share you Co-Versatile's insights and results in delivering a rapid response to these emergency situations and global disruptions. So let me tell you some words about our agenda. After my introduction, we will go on with our main starting speaker today, Professor Elena Revilla. I almost said main speaker, but obviously she will just make the ground for the state of the art of the topic today, so supply chain. So she will give an overview about achieving supply chain resilience to face disruptions. Then from 1 to we would go on with preparing your enterprise for sudden changes in the market demand in the consideration of supply chains with Dr. Matthias Wangenheim. And as a good example, as a best practice, Dr. Saskia Sardesai will go on with simulation of pandemic risks. So I would just like to ask to the floor Professor Elena Revilla, and let's just introduce her in some sentences. Professor Elena Revilla is a pioneer in the study of organizational learning. She is a professor of operations management at the IE Business School in Madrid, Spain. Her primary research interest is organizational behavior in the context of operational and supply chain management. Dr. Revilla's work has appeared in many prestigious publications, including the Journal of Operation Management, Journal of Management, the International Journal of Production Economics, and the International Journal of Production Research, among others. So please welcome Professor Revilla, and I'm asking her to give the overview of the state of the art in this topic.
Okay, thank you, Aniko, and hello everyone, good afternoon. Resilience is increasingly appearing in the agenda of supply chain executives. That is because the link between resilience and disruption. During last year, organizations in nearly every industry faced disruption on a scale that have never seen before. In this slide, we can see chip shortage, truck driver shortage, and also material shortage in the pharma industry. The war in the Ukraine is bringing us new disruptions. For example, rail between China and Europe can no longer. Our next slide, we can see the consequences of these disruptions. We have operational consequences, financial consequences, and reputational consequences. They are so important that media has given it a name, the Great Supply Chain Disruptions. In the next figure, in the next slide, we can see what is more important, and it is that the supply chain disruptions are here to stay. In this slide, after COVID, the level of disruptions has remained stable and comparatively high. As I said, this means that we will have to deal with disruption in the next years. Why this is happening? For the past decades, the search for supply chain efficiency has made them leaner and more global, creating a weak balance, a fragile supply chains. The globalization has made increasing complex supply chains with many nodes and cultural heterogeneity. There has also been an extensive use of lean practices. They rely too much on outsourcing, single source, just-in-time delivery, little stock, and short life cycles. As a result, supply chain leaders are becoming aware of the need to build more resilient supply chains. If we see our next slide, you can see that resilient firms are less vulnerable and more capable of dealing with all types of disruptions because they are more robust, they are able to minimize the impact of disruptions, and they are agile. They are able to return to functionality once a disruption has occurred. How to build a supply chain? In this new figure, we could see that supply chains resilience cannot be adjusted or cannot be achieved just by developing a couple of isolated practices. It requires of a holistic approach through a set of practices that can be categorized as proactive or reactive mechanisms. Proactives assume that disruptions will eventually happen and prepare the firm to deal with them by working at the core of the supply chain, the design of the supply chain, its product, and its processes. On the other hand, reactive practices are deployed once the disruption hits the supply chain, with the objective of containing or mitigating its negative consequences. And all this should be grounded by digitizations. Let's start with 6 leading practices that companies should take into consideration when designing a resilient supply chain. In this new slide, you will see this is a practices, and I will be presenting them one by one. First, redundancy. Redundancy refers to use backup resources so that operation can continue during failures of critical parts. Typical redundancies are holding extra inventory, alternative suppliers, alternative production plants. Second, the location of suppliers, distribution centers, production plants, conditions how the supply chain reacts during disruptions. It affects the time it takes to notice that something is wrong and determine the reaction times once such disruptions is identified. To avoid future disruptions, for example, the European Union is providing economic incentives to producers to locate in Europe. reshoring is not always an option in terms of cost, but nearshoring might be an alternative. In this line, it's also important not to have the operations concentrated in the same geographic area. Our third mechanism is working in the product design. Products should be designed to easily adapt to different potential uses or configuration. And in this respect, modularity and postponements introduce a lot of flexibility in the design. By standardizing components and interfaces between components, modularity avoids the failure of one part that does not affect the entire systems. Postponements refer to the design of a group of family products with a core elements that can later be easily customized to produce different products. Next, we need to work portfolio management. Portfolio management refers to the number of products that a given organization manufactures. In times of disruptions, limiting options could help streamline production facilities, reduce logistic downtime, and ultimately help to keep customers satisfied. It requires a flexible planning that takes into consideration the needs for manufacturing equipment from different production rates, as well as the staff requirements to operate in such flexible environment. Next, we need to talk about end-to-end visibility. Visibility creates awareness of the vulnerabilities of both the supply chain and its operating context. It facilitates supply chain mapping and monitoring, allowing a real-time evaluation. And finally, from the proactive by design, we have the logistic. It is important to ensure that goods can be transported on time during disruptive times. At this respect, logistic diversification and strategic agreement with logistic providers could be also helpful. Now we'll go with the practice that allow companies to be reactive. Proactive resilient practices need to be complemented with reactive ones. Once the disruptions even happen, firms need to quickly react and deploy a series of mitigation tools to minimize the negative impact of such disruptions. Let's start with risk management. Risk management practices offers a formal response to deal with disruptions. Here in this slide, we have highlighted business continuity plan and incident management. Business continuity plans provide a roadmap to enable ongoing operation before and during execution of disaster recovery. Incident management plan help quickly detect signals of disruptions. To be reactive is also important to have a dynamic business model. It adapts the business to the new disruptive context. From this point of view, disruptions are seen as opportunity to exploit new markets. For example, Wamos Air, a Spanish airline whose main business revenues came from transporting passengers to cruise in the Caribbean. With the tourists virtually stopped everywhere, the company worked fast to react to the new circumstances. They adapted to the new demand by quickly converting 70% of their fleet into cargo planes. So, building supply chain resilience required these two complementary approaches mentioned above, proactive and reactive. But for making this work, these two approaches has to be connected. In this slide, we can see that to this end, supply chain required digital technology and rich data that spans end-to-end. First, we have end-to-end connectiveness. It is important to have an end-to-end connectiveness integrating multiple data sources in real time. It facilitates the deployment of the supply chain visibility and integrates it in the deployment on risk mitigation practices. Second, it's also important to establish specific supply chain goals and create KPIs to monitor performance. This facilitates a balance in the trade-off between resilience and efficiency, or between redundancies and cost savings. And finally, it's also important to develop analytic models and create the necessary insight to operate the complexity of supply chain resilience. Analytical models can be replicas of, for example, value at risk of the supply chain infrastructure and asset. The engine that put this model into actions include different analytic techniques such as predictive, prescriptive analytics, or more advanced techniques based on machine learning and artificial intelligence. Summarizing, supply chain resilience requires a holistic approach through a set of practices that integrate proactive mechanisms working on supply chain designs and reactive mechanisms for the deployment of the reaction. And all this should be grounded by digitizations. I hope that this framework help you with to deal with the disruptions and introduce resilience in the firms. Thank you very much for your interest.
Thank you very much, Elena, for this foundation of our topic for today. And I can see that there is a question here in the internal chat. I just read it out. Have you seen any good practices where an SME was mastering the response to a shock? So can you just tell us some words about that?
It depends. I think it depends a lot on the company, of the firms, of the situation of the company. But once I think once is innovate to react quickly with dynamic business model, to understand disruption more as opportunity, as shocks, to don't allow to the company to react. I think it's important to see this, how I can take the advantage of this situation and to react. And in order to do this, it's important to be quite flexible.
Thank you very much. I would like to thank again for Professor Revilla's presentation, and I'm calling to the stage our next presenter, Dr. Matthias Wangenheim, who will go on with the topic, but from a more practical point of view. He will tell us about preparing the enterprises for sudden changes in the market demand, considering supply chains. So let me just introduce you, Dr. Wangenheim, in some sentences. Since 2013, he is an assistant director at the Institute of Dynamics and Vibrations Research at the Leibniz University of Hannover, Germany. Matthias participates in several international Horizon 2020 and Horizon Europe research and development projects, as well as in numerous bilateral product-oriented industrial collaborations. Prior to his academic career, he was working for companies in the aerospace industry as systems engineer, and he holds a PhD degree in mechanical engineering. His thesis was about friction and wear prediction of pneumatic industrial seals. Uh, you have met Matthias in one of our previous sessions, and now I'm handing in the presentation to him again to talk about supply chain resilience in market demands.
Yeah, thank you, Aniko. Welcome, everybody, to my presentation today. So I would like to analyze with you the effect of the supply chain on our enterprise, our example enterprise, which I will present soon. When I speak about supply chain, it's not only the external effects of the supply chain or problems with the supply chain, but also internal effects on our factory, which we have to take into consideration. This scenario, which I want to present here, at first, we are in a pandemic situation or at the beginning of a pandemic situation, and this leads to a sudden increase of the demand for face masks. And our factory, we are producing face masks. Our SME, which I will talk about, he has to prepare his manufacturing line to produce face masks. And here the example are silicone face masks, which are reusable, and I would like to present in the following. I want to identify together with you needs while we are reconfiguring our manufacturing line with respect to supply chain. But again, I want to differentiate between external and internal effects. I have to present our team again, that we get a clearer view what I'm talking about. In the design and manufacturing of rubber or silicon rubber face masks, there are involved 3 SMEs. The product design was a collaborative design between all 3. This is a mold maker based in Italy, ORP Stampi. This is SCM Aeronautics, who are situated in Israel. They are finally molding these parts and producing these silicon rubber face masks, and they use the molds of ORP. On the bottom left, we have the laser engraving company, ML Engraving. They're again based in Italy. They treat the surfaces of these molds that our mask at the end has a nice velvety design. You have to wear it for a longer period, so you want to have a comfortable mask. So the flow of the material in this case here is the mold maker builds or manufactures the mold. It is sent to engraving, to ML, and then the engraved textured mold is sent to SKM for production. During the design, they had some support in terms of engineering. These are process simulations from ITA Innova based in Spain, and some rapid prototyping for the first rubber prototypes, which is done by us here in University of Hannover. And we made use of some business consultancy, which was enabled by our co-versatile project in terms of risk awareness, together with IE Business School, led by Professor Elena Revilla, which we just listened to, and supply chain analysis, which was done by Fraunhofer IML. Our colleague Saskia will have the following presentation on the supply chain analysis. Furthermore, we had help in terms of training and certification needs from HSMI and SUPSI. Today, we will concentrate on supply chain analysis. Let's recap the mask design, which is probably necessary to understand the supply chain in our project. We were asking customers on special properties which a rubber face mask should have so that they will have a market acceptance. On the left-hand side, you see a word cloud with the most common answers, and the most common was high wearing comfort. Especially, we are competing to the well-known non-woven or paper masks or cloth masks. We need high wearing comfort, and on the top you see velvety texture. This is considered as the most important in terms of wearing comfort, because you have to wear the rubber mask directly on your face for a longer time. Then it should be reusable, which is a big advantage in terms or in comparison to these disposable masks which are on the market. If it's reusable, it is more sustainable, but we have to think about two aspects there. It has to be washable, and the filters have to be exchangeable because the rubber itself cannot filter. Some more aspects which were mentioned is transparency, so that you can see the mouth while speaking, ease of breathing, and no fog on glasses. This probably is easier to realize with the rubber mask because you can introduce a sealing lip on your face and on your cheeks that the wet or humid air doesn't come into contact with your glasses. So the mask will be composed basically of two materials. One is the rubber, the silicone rubber. We chose to go for a solid silicone rubber, no liquid silicone, a solid silicone, because it's easier to process. There are on the market medical grades available, which is important in terms of certification, which we learned yesterday. Again, it is good to process with molds that do not have any special requirements. It's non-toxic, which of course is very important. And in our case here, we chose a material which is delivered from an Italian rubber compounder. I forgot to mention, I mentioned on the team slide that our company SKM, which is producing the slides, is based in Israel. In Israel, there's no rubber compounder, so we need to transport from a rubber compounder the raw material to Israel, to SKM, and this is for sure has to be considered when we talk about supply chain. So supply from raw material by probably air or ship transport to Israel and further to the company. The second material which we have to purchase is the filters. We analyzed two different filter materials in our project. This is a cloth filter. This cloth filter was delivered from another Italian supplier. Of course, this cloth has to fulfill FFP2 requirements or N95 requirements. There are types of cloth who do that. And the second alternative is non-woven filter material. This was delivered from an Israeli filter supplier. Again, a very important supply chain consideration here. From Italy, we have to transport via air or via the ships. You have to pass customs, by the way. And the transportation within Israel, of course, is shorter and probably less risky. Again, concerning external aspects, the supply of the rubber material as well as the filter material is important, and we have to consider that here. Now, we chose the materials for filter and rubber. We chose a texture, and concerning the geometric design, to get high market acceptance, we need adjustable strap strength so that we have not only a nice texture, but the tension on your ears and on the face should be under control. The filtering and the sealing have to be work properly, of course, and the whole product has to be fail-safe in use. These are important aspects for product certification, but not as important in terms of supply chain consideration. And again, the mask design was a collaboration between ORP, the mold maker, and SCM, the rubber manufacturer. Now we have to be able to produce these masks. Therefore, we need a mold. This mold was designed in a way that it fits to the most common presses within Europe. These have an area of 500 by 500 square millimeters. Inside, we can fit 1 or 2 cavities easily, so we can process 1 or 2 masks in this design at simultaneously. If we want to process simultaneously more than 2, we need a larger press with larger area. We have textured the insert, which is in green here. This helps us to easily demold without any manual extra work. And we optimized the injection inlet so that one press cycle gets reduced as much as possible. So we are in the range of a minute that we can produce 1 or 2 masks simultaneously. Another advantage also in terms of supply chain is that this can work with all types of solid rubbers, or nearly all types of solid rubbers. So in case of a shortage in supply of our type A grade, medical grade silicon rubber, we can use other silicon rubbers if necessary, for example, food grade. We decided to go for a technology called transfer injection molding, with the main advantage that we have no deflashing. This means there's not so much rubbish at the end after each cycle. Here we come in contact with the supply chain again. First factor I already told you, we are able to process different types of rubbers with the same press, which is important if we have shortage in a certain type of rubber. But secondly, the mold itself, this is an important part of the supply chain if we want to prepare our factory to be ready to produce masks, because preparing a mold, designing and manufacturing a mold is quite a long-term process. Yeah, we are talking of several days there, which pure machining time that we can process such a big type of mold. And in addition, we have to texture the mold in another factory. So we will need several days there that we can supply our factory with a mold. Now we received the mold and we want to start or prepare ourselves for manufacturing. There are different steps which we have to follow to process a mask. We receive material, raw material, so the rubber, uncured rubber. This has to be handled or stored in a special way. This has to be handled during the factory. We have to follow different quality assurance processes before molding, during molding, and after molding. The molding process itself is very well structured. The filling time, the pressing time, heating, preheating curves, demolding, and then the transport to the so-called post-curing procedures. This post-curing is a very important step in medical grade products because we need a full cross-linking of the material. This prevents the material from off-gassing toxic gases, which you don't want while wearing the mask. These steps are very well under control. We need them to get our processes certified. I now want to analyze all these steps, or most of these steps, if they are affected by the supply chain. We are now in the initial situation before start of production. So our SME, SKM in our case, has uncured, so raw rubber compound on stock. And we already have molds or a mold on stock. The purchase order we have received, as an example, in parallel from professional and from private customers. We will consider this in the supply chain analysis or supply chain simulations later in the next talk as well. In turquoise, I marked some words here. SME has rubber compound on stock. This is very well affected from the supply chain. On the one hand, we have to get new rubber compound from our supplier. The same is with the mold or molds. On the other hand, the purchase order, which will tell us how many masks are ordered, but also when they expect a delivery of the masks, those affect both the rubber compound in our stock and the number of molds in our stock. The number of molds we need to feed the market demand. This is an important input from our supply chain analysis. Now we want to prepare our manufacturing. The first step when we receive uncured rubber and take it out of our stock is we have to prepare it. This rubber has to be milled first. So it is flattened, it is mixed a little, it becomes softer due to this milling process. And after that, we will use a slitter to cut it into portions which are required for the mold. We consider these steps, both milling and slitting, as uncritical in terms of the supply chain, in terms of feeding the demand of our customer, because these processes are comparably quick. They can be done independently from the molding process, and we can process quite a lot of material simultaneously. So even if there's a very high demand, it's quite easy to react with the rubber milling and the rubber slitting processes. So this step we consider as being uncritical in terms of the supply chain. Every time we get a new delivery of rubber, we have to do some quality inspection at first before processing the rubber. For example, we analyze curing characteristics. We analyze the hardness of the cured rubber, tensile strength tests, and so on. Again, this is also considered uncritical because it is independent from the material flow in the factory. These machines, these analyses are independent from the process itself. They are standardized processes, and we do not expect to receive a lot of batches at the same time, rubber batches, so that there probably will not be more quality inspection effort necessary than in normal days. So uncritical. Now we have to prepare our molding presses. Now on the left-hand side, you see a press. Here, this press has actually two presses, so we can process two molds simultaneously here with one worker. And on the right-hand side, you see the post-curing ovens. So after pressing, we put our molds into these ovens, and for a certain time, they have to be heated. This is important for degassing. Both we consider as a potential bottleneck. If we have a very high demand, then we probably need to dedicate more presses simultaneously for producing masks. Yeah, so it's not only that we need the molds, but also presses who can produce masks with these molds. The same is with the post-curing ovens. We have to post-cure our medical rubber masks, so we need enough ovens for this procedure because it will take some hours. After molding, we have a parts quality inspection. For example, we inspect the geometry. We look if there are any air pockets inside, so entrapped air bubbles, the color, the appearance, the transparency of the mask, and several more criteria are checked here. This we consider as uncritical in terms of supply chain. This again is a standard process. This can be done by many people in parallel. So by employing more people or using more automatization, it's possible. The last step, packaging and delivery of masks and filters, we consider as uncritical to feed the market demand. So when we do this identification of our external and internal processes, we try to identify potential bottlenecks, especially for periods of high demand. Internally, what I showed on the previous slides, there it's very important to take into account the number of molds to have on stock to feed the market demand. Each molding cycle takes a number of minutes, between 1 and 5, depending on the part. The same is how many presses do we have to dedicate for mask production. Two slides ago, I talked about the post-curing ovens. Post-curing is a long-term process. So there's not manual work required, but just time. So we have to consider the correct number of post-curing ovens. And this is directly affected by the supply chain, by the end of the supply chain, namely the market demand. And internally, we have to take into account the shift organization. Maybe we even have to employ additional personnel. We have to introduce 3 shifts or even 4 shifts. So even organizational changes have to be made if the market demand is very high. Externally, we identified the volume per order of uncured rubber as critical. We identified the order frequency of uncured rubber. So not only how much We order per order, but if we order the rubber once a week, twice a week, or less often, with lower frequency. The same is with order volume and frequency of the filters. So this is easier to transport. It's easier to have higher volumes on stock. So this is why I put it into brackets. The rubber has to be stored in a cool area, in a dry area, and there we need a lot of space. This is easier with the filters. So we see higher risks in the uncured rubber. And finally, we have to take into consideration potential transportation risks, which might occur. I told you we import raw rubber from Italy to Israel, including special transport modes like air, like ship, and customs procedures, and so on. And the emphasis of the next talk will be on these transportation risks and their potential effects. We had support in these reconfiguration, upscaling, and supply chain considerations from IE Business School. They helped us with the risk analysis, and from Fraunhofer, who supported us with supply chain analysis. Thank you for your interest. I'm done with my presentation.
Thank you very much, Matthias. No questions yet, and as our time is going quickly, I would just like to encourage all the participants to visit us at the expo, and you can ask Matthias or his colleagues directly after the end of our session. So I would like to thank you, Matthias, again for your presentation.
Thank you.
And I would like to ask our next presenter today, Dr. Saskia Sardesai, about simulation of pandemic risks. You might heard that our presenters are referring to each other, so you have the feeling that these researches and activities are building on each other, and we are in close connection with each other during the project. So Saskia will also talk about the simulation of pandemic risk. Let me just introduce her in some sentences. Saskia Sardesai works as a senior scientist for SCM Research and Strategy at the Fraunhofer Institute for Material Flow and Logistics in Dortmund. She coordinates research and writes proposals for the department Supply Chain Engineering, focusing on topics of supply chain management with a specialization in risk management, discrete event simulation, and possible interfaces to application areas of artificial intelligence. Saskia specializes in designs of logistic structures and processes with special focus on global supply chains and supplier management. Prior to Fraunhofer, Saskia worked at the Kühler Nagel India Ltd for several years in the Department of Contract Logistics, which helped her gain a vast experience in logistics concepts applied in several industries, and she has just obtained her PhD in the past weeks. So, Saskia, the floor is yours.
Thanks so much, Aniko, for the nice introduction. Yes, so I will talk about simulation of pandemic risks. So we just heard from Matthias Wangenheim about the issues which they faced once they wanted to produce the masks. So I will just pick that up again in the later slides and talk a bit about general risk simulation and the effects of it. So I come to it, and I just so we have now first of all only the pandemic risk which we were talking about. But in general, we have to, I mean, after the pandemic risk, we had like now several crises coming up. One of it now, the Ukrainian war, where we have to think about more in scenarios where we need to evaluate how the world will change and which kind of impact the Ukrainian war will have on the supply chains. We already notice it in several areas, and we need to actually think of these of several scenarios how to act against the Ukrainian war. So, but not only the war items, which is like having a global impact, but also very local crises are happening. We had it in last year in Germany, that we have at flooding in the western part of Germany, also affecting the Belgium area naturally. So also the local issues which we are facing, where there are suddenly some suppliers which we cannot ask to deliver the parts anymore, because just their plants are just flooded and they cannot produce at the moment. Similar is happening now in India. There we have this heat wave coming up, which is like quite unusual for this time of the year. So the heat will at least last for another month. So also here we need to see how do we act. How do we have suppliers actually on that in that area? Do we need to somehow collaborate with them to see that we can actually receive the parts still on time? Also here, one more crisis event which was happening or is happening currently. And naturally, also events like the Suez Canal. Normally, we actually put up an entry probability which is extremely low, but it just happened actually in the or during the corona pandemic. We also had this risk. So also here we had to see which kind of containers are involved in the way or which kind of containers are actually on the ships which have to pass the Suez Canal. So all of these events are influencing the supply chain, and I just want to shortly show the strong interconnection of the supply chains on the example of an electronic component, but this is also valid for all medical products. So if we have here yes, we just have in the first go here the raw materials, the mining of materials on the rare earth, which is then produced here in these areas, and then these items are actually sent over here to the US manufacturer from two ways here, and then further on after the semiconductor, after the production of the components, such as the wafers, the semiconductors, and the microchips are then produced. Then we actually assemble them to larger components, which is happening partly in the US, but also partly here in Asia. And then again, these ones are then sent back to be assembled, for final assembly and for tests in the Asian region again, and we have the shipping of the final products to the end consumer. So, and then finally we have it here in the European market. So if we have a look at these different transport lines and the interconnection between the different countries, we actually see that a lot of these events which we had are affecting those. So we have in the US very frequently some blizzards, some hurricanes, which we have to take into account. We have in Asia some droughts, some earthquakes, quarantines naturally at the moment with a big lockdown in China. And we also have to consider some political conflicts. Then we have the war zone here at the moment, which is affecting all the transports which are going here into, which are blocking this airspace over here. And in general, we come here to a strong increase in transport time, not even considering all the harbor blockages which we have currently, since the containers are just piling up at the harbors. So it's getting so the impact of these kind of crises need to be evaluated, need to be considered, and then we need to create some scenarios out of that. So this has also been mentioned earlier on in the very first presentation of the series, where Kumadev Chatterjee was mentioning that there are 3 elements of resilience in public health. So he mentioned about robustness, about agility, but also about visibility. So once we have the data in the supply chain, we can also have a look at a scenario analysis and the capability of the supply chain, which we have to deal with and which we have to steer. So I get into these points here in more detail. No, it's okay. So in order to deal with this situation, and also to have a look at the supply of the materials, we have within CoVersatile set up 2 simulation models. And the one is aiming for a rapid redesign of the supplier structure in order that we have the material availability ensured. And there we focus on the lead time aspects and the production capacity at the suppliers, and make a bottleneck analysis then. So which kind of supplier is able to deliver the parts on time, and where do we face issues? So here it's just about the lead time as such. Now in the second model, we integrated, we actually can set up a complete new supply chain structure, and we evaluate pandemic risks. So here risk factors can actually be integrated, and we have then a report on the capacity availability, the lead time, and the logistics costs. So I will focus on this second model a bit further. This model has been based upon the use case which we just heard from Matthias Wangenheim, where you actually got to know the supply chain about the mask production. So we have the masks mainly being required by the hospitals, but also by general people, by the general by everybody actually. From so we had 2 orders. Once we had to supply to hospitals, but there were fixed orders behind it, and once we had an open order set from the general public. Then we had the masks which were produced here at SKM, and you also got to know the suppliers here, Mesco, which was supplying actually the silicone rubber. And in case it was not available, or the quantity was not available here at this supplier, we had also the possibility to supply a different type of silicone rubber, and here we integrated the possibility to have 2 different suppliers to ensure that the supply of silicon is that the material for silicon is actually available. And then we had we integrated actually the lead time. Had also a look which is the required lead time from the supplier, and what is the maximum lead time here also until the final hospital order. And we had a look at the total transportation risk if we set up a supply chain completely anew. And out of that, we had like different supplier options integrated, and also some risk scenarios involved. So how does it look then in the simulation model? So we had here the suppliers. So here the supplier one, which was then Mesco, and 2 additional suppliers to make it easier for the users to implement the substitutes and the capacities for those substitutes. User. If I refer to a user, I actually talk about the company who wants to use this simulation service and wants to evaluate the lead times and the costs in case there are pandemic risks involved into the supply chain. In order to integrate this risk here, we have like one normal distribution channel, which is like considering the normal lead time, and we have a lead time with a certain delay involved. And then, in order to differentiate between a transport which is with risk and without risk, we had to involve here some routing tables. And then finally, the production is happening here at the plant at SKM. The whole simulation is then triggered by orders. So you integrate the amount of orders which you want to produce finally, either for the hospitals or for the general public. And then the simulation can start and evaluate the lead times which we have. Okay. So how do I integrate then the risks? So we now considered certain pandemic risks which are involving or which are causing transport risks. So mainly, we had to deal here also with the transport to Israel. So there was also customs involved. We had during the pandemic also border closures. So also that caused a lot of delay in the transport, even in between the European countries. And then we said, okay, fine, we can actually for each supplier we integrate a certain delay, and we estimate, okay, a delay, a normal transport would be 5 days, and in addition, if I have to consider now the risk, I estimate the delay in transport to be between 5 to 10 days. So there's a normal distribution. So the simulation will then choose any time in between these this time scale actually. And then we come to the probability, which is entered then here in this part. So here it was a probability of 10%. So how does it look like now as we have a look into the report and see the orders of once we see the result for transports without risk and ones with risk. So we see here that the orders which were timely fulfilled, that was like nearly 95% in the normal setting, while with the risk setting, it's immediately decreasing to only 87% in the service level, so quite high. So and then we have to go into the evaluation. What can we do about it? And there are some further reports are supporting this analysis, and especially it's showing how what kind of delay or what kind of different order lead time and transport time is actually so the transport time is actually compared with the order lead time, which was given to the supplier. And here one is seeing that one needs to inform the supplier a lot earlier that items are required and that the transport has been triggered at least 2 days earlier. On the whole setting, you can actually so that's the complete setup. I just go to the last slide here directly. So with the help of University of Westminster, we integrated this simulation into the digital technopole. So you have once the user interface where you can integrate the supply chain data. Then the simulation is started and working in the background. and you get the results in form of a report summary here in this overview, which is also stating the transport risk, the transport costs, the overall transport costs, and the transport cost per item produced. And that's how I want to close my session, and I thank you for your interest and for being online.
Thank you very much, Saskia, for your presentation. Are there any questions to Saskia, probably? Not that I see of in the comment section, but this is not a problem because, as I have mentioned, you will have the opportunity to contact our presenters directly later on. So I would just like to thank Saskia for her final presentation. Thank you again. And with these words, I'm sad to close our session today, but before you go, I would just like to tell you some words about the future cooperation possibilities. So those of you who've been with us in the first day, you might have heard my colleague's presentation about the Digital Technopole, which is our meeting place for the future. And if you don't mind, I would just like to go through the Digital Technopole very, very quickly by sharing my screen. You can also, okay, let's just share screen. Okay, I hope it will be fine. Yes. Can you see the Digital Technopole right now? Yes, okay, so you can see that I'm logged in. I've got an account. I would like to ask you to register for an account. This is not an automatic registration, but my colleague Sebastian will take a look at your registration and approve your registration, because you have to register as an SME, which needs to have a legal entity. But after you are accepted, you will have the opportunity to take a look at our community. So you can see that the members are already here. So there are already some people joining us from this conference, which I'm very happy to see. And if you take a look at the marketplace, you can also see who the participant organizations of the Digital Technopole. So you can see that these are mostly the project partners of the co-versatile, but from the community there are some other partners joining us continuously. So here you can see what applications we have in the Digital Technopole, what are the consulting opportunities of the Digital Technopole offered by the different partners, what are the techniques which we are focusing on. And you can see that if I click on business consultancy, it just takes you to the different consultancy activities which I've been showing to you previously. So this is a kind of an intertwined solution. Also, you can choose the sectors which you are interested in. For example, electrical equipment, not yet, but you can take a look at manufacturing, for example, and you can see those applications and consulting opportunities which are linked to manufacturing. So, and here again as the partners, as I mentioned before, so you can just take a look at the different participants. For example, here is Glasgow. They are the operators of the Digital Agora, the Digital Technopole at the moment, and you will have the opportunity to get in touch with all of the partners and participants here. So for example, let's take a look, HSSMI, one of our presenters. So you can see that there is an introduction, there is a website, and you will, when you are visiting the marketplace and the support and the community, you can see the different members. And what is very important in the community menu, there is this menu point so-called matches. You can see that there are no matches yet, but I would like to urge everybody to click on this created matches and click on the create match option, where you will have the opportunity to ask for any meeting which you would like to arrange with the different partners. So you can specify which technique you are interested in which sector, for example, in manufacturing section. Here you can type some more text about and what is your objective, what are your requirements, and when you push the create button, the match will be created. And it means that one of our partners will check it out, possibly me or Sebastian, and will bring you to the required partner or the required person or the required member who you are interested in. So for example, myself. So this is a member. You can see where we are coming from, which is our organization. So what apps and what consultings we are offering. So I think it's quite a good overview of what we are offering to you. And in the final part of our conference today, the active presentations are finishing, but from 2:15, so actually just after I'm finishing here, to 2:30, we are asking you to visit the digital Technopole. Please register, browse through it, and express your interest. We will also be waiting for you from 2:30 to 3 p.m. today at the expo, where you can find the entrance on the left-hand side of your screen. And until 3 o'clock, your partners will be waiting for you there. So all the co-versatile participants and consortium members and the presenters, so you will have the opportunity to contact us directly. Also, after finishing this conference, which I think was quite a successful 3 days, you will still have the opportunity to visit our website in the co-versatile website. Also, in this Hopin page, you can check the recordings. So all the previous days' recordings are available on the also on the left-hand side menu of your Hopin screen, so you can watch one of the sessions or presentations if you missed it. You can visit us or contact us directly for individual consultations. So besides the expo and the digital Technopole, one of our tasks is to create these matches with you between you and the participants of the project, and my organization Innomine is in charge of it. I have already received some requests for possible matches, so please feel free to either send me an email or you can contact me right now during the expo. And also you will have the opportunity to download as a take-home message the brochure, which can be found also here in the Hopin screen or from our co-versatile website, which is a kind of summary of the conference, the topics, the presenters, the introduction of the partners, so the co-versatile partners, and our services, what we are offering you. And last but not least, our project is going on for another 6 months. These offers are for free during the time of our project going on. But after our project closes, the digital technopole will not go away. It will be there, it will continue, and you will have the opportunity to use all of these offers and services in the future. So again, with these closing words, I would like to thank again everybody, the participants, the presenters, and last but not least, the organizers, our invisible helpers in the background, especially Elena Reinemann and Beate Schaefer from the EIT Manufacturing, who you didn't see, but this conference would have been impossible without their help and organization. So thank you very much again. See you at the expo, at the Digital Technopole, and hope we can keep in touch in the future. I'm wishing you goodbye, rest of the week, a nice weekend. And before we leave, let's just watch a short video about the co-versatile project. Thank you very much.